Can you hear me? Okay, so today we'll proceed with the topic of polymer processing. Boleh dengar ya?
Boleh, Doktor.
Alright, okay. Just like to confirm it's recording. Yeah. Okay, before this we have studied about the shaping metal. Okay, so now today we'll proceed about the plastic polymer processing. Okay, so we know that to process polymer and to shape polymer is much more easier and easier compared to metal. Yeah. Okay, so here you can see the sample of processes that we need to use to shape the polymer. For example, like we can perform injection molding, blow molding, okay, casting, compression molding, foam molding, rotational molding, thermoforming, extrusion, and many more. So I hope I can touch all this by today. Okay, so these are the 10 topics of shaping or processing of polymer that I will cover today. I will begin with extrusion, then I will touch on the injection molding, blow molding, rotational molding, thermoforming, compression molding, transfer molding, casting, foam molding, and finally processing elastomers. Okay, let me begin with extrusion number one, yeah. So extrusion is the largest volume of plastic produced using extrusion, and where the raw materials in the form of thermoplastics, pellets or granules or powder are placed onto a hopper here. These are the plastic hopper, yeah, and fed into the barrel of screw extruder. So you can see here, these are the screw extruder. So complex shapes can be extruded with relatively simple and inexpensive dies. So as you can see here, these are the die. These are the die, steel die. Okay, right, and this is the plastic powder, and then these are the extruder, yeah. So here you can see we apply heat here. So let me go to next slide so you can see clearly. Right. The green one here, this is the part lah, the produced part by extrusion. Yeah. All right. So from this figure, you can see clearly that you have to understand basic, basic terms in this device. For example, like this machine. For example, like these are the hopper. So this is the feed section. I divided to three. I divided the screw to three. The first one is feed section. This is melt section, and this is the melt pumping section. So first we put the materials in the hopper, and then these are the feed section. So then we apply heat here. So that's why they put here in under melt section. Okay, and then we start to pump. This is pumping section. So these are the schematic illustration of a typical screw extruder. Yeah. This one you can ignore because we didn't discuss on details about the calculation of this part. Yeah. Okay, you can exclude number B. All right. So here, as I mentioned just now, we divided the screws to three distinct sections. The first one is feed section, melt section, and melt pumping section. Okay, so the feed section conveys the material from the hopper here into the central region of the barrel. So these are the central and the melt section. Okay, so once we pass the material to the melt section, or we call it compression or transition section, yeah. So where the heat generated by the viscous shearing of the plastic pellets and by the external heaters causes melting to begin. So now they are starting to melt. Okay, so then we pass on to metering or pumping section, where additional shearing here at a high rate and melting occur with pressure building up at the die. So if you can see here, this we have this screen here, wire filter screen to filter the unmelted material. Okay, so this is the die here. This is the die. See die, this one. So then we force it to get the extruded part here. Okay, so if you can see this figure, show it in the detail, yeah. So this is the melt inlet. So this is the die. Okay, if you look at the right hand side, so this is the melt distribution manifold. This is the die bolt, and this is the adjustable lip. Yeah, this one is fixed. This is adjustable. Okay. All right. So at the bottom B, you can see the round die shape. Yeah, round die for producing rods. So this one on the left, so we have B, C, and D. On the left is the die shape, and on the right here is the extruded product. So this one is the die shape, and this is the extruded products. And see, this the die shape like this. The die is like this. The final product is like this. Okay, and this one, the die shape is like this. The final product is this shape. Okay, this is the extruded products. Yeah. Yeah, this one is one of them. Just to show it to you, the die exit shape is like this. So this is the die. The shape is here. Yeah? Sorry, the shape is here, like this. So this is the die. Okay, so the product shape is like this. So this is the extrudate. Extrudate is the product lah. Okay, the component that are produced using the extrusion machine. Yeah, so we call it extrudate. So the product is like this. Even though the die exit shape is like this, but the final product is like this, the extrudate. Yeah. So you have to remember, yeah, this shape. Right. Here you can see in details. These are the mass flow in this direction. Okay, mass flow in this direction, and here we have the screen, yeah, to filter the unmelted material. So this is the polymer melt, and this is the die. This one is the die. So the extrude, and this the die opening. Here, these are the details lah to show it to you. Here the extrusion die is this shape, and the extrudate or profile is like this. Usually it's a bigger, yeah, bigger than the die, the extrusion die. Okay, here you can see these are the output. Okay, and then straight away we put to the cooling process. Yeah, so these are the machine. Sorry. Okay, here you can see detail at the bottom. Here's the simulation. These are the extruded section. Yeah, so these are the die, and these are the extruded. Okay, so at the bottom here example, these are the die, and this is the parts, the extruded parts. Yeah, so this is the die, and this is the extruded parts. Okay, the control of processing parameters such as extruder screws, rotational speed. So we have to monitor the speed, and also the barrel wall temperatures, the die design, and also the rate of cooling and drawing speeds. So those are the parameters that we have to monitor. Okay, in order to ensure the product integrity and also uniform in terms of dimensional accuracy. So we have to monitor these four parameter. Okay. We have also miscellaneous extrusion processes like plastic tubes and pipes. Here you can see these are all the tubes and pipes. Yeah, so these are produced in an extruder with a spider die. Here you can see the spider die, where the spider die is here. You see, these are the spider. Okay, so the die is here, the spider die. Okay, so once the push to this area, to this direction, okay, so we can get this component, yeah. So these are the produced extruder with a spider die. This is spider die, yeah. So fiber or wire reinforcement also may be fed through specially designed dies, yeah. So these are the specially designed dies to produce the reinforced hoses that need to withstand higher pressure. Okay, by using the spider die, you can have the output that can withstand higher pressures, yeah, especially pipes, yeah. Okay, so next is about rigid plastic tubing, where extruded by a process in which the die is rotated. So now the die is rotated. So rigid plastic tubing causes the polymer to be sheared and biaxially oriented during extrusion. So this can result with higher crushing strength and higher strength to weight ratio, right? So these are the output of the rigid plastic tubing. Next, we have the co-extrusion. Co-extrusion involves simultaneous extrusion of two or more polymers, yeah, through a single die. Like this one, you can see this is the die, and then we have more polymers, yeah. So it's a mixing, yeah. So the product cross-sectional thus contains different polymers, each with its own characteristics and functions. Okay, so we call it co-extrusion, yeah. Next is to show it to you the pellets. The pellets itself, used as raw material for other plastic processing methods described in this chapter. Okay, pellets also made by extrusion. Okay, so a small diameter solid rod is extruded continuously and then chopped into short length. We call it pellets. Yeah, with some modification, extruders also can be used as simple melters for other shaping processes, such as for injection molding and also for blow molding. We will discuss about the details of injection molding and blow molding later. Yeah. Here I have a video. You can watch the video later, yeah. So you just watch until minute 7.5 because the rest after that is not covered in our syllabus, yeah. Okay, next process is injection molding. So injection molding is similar to hot chamber die casting. So the pellets or granules are fed into the heated cylinder, okay, and the melt is forced into the mold either by a hydraulic plunger or by rotating screw system, okay, of an extruder. So here you can see these are the molten uh, plastic, yeah, okay, and then they inject here, right, and then we wait until cooling, then we will eject, yeah. So the part is ejected, right, and then it's dropped down, okay. So here make sure that you have to be familiar which one is the die, which one is the cavity core, which one is the gate, okay, which is the runner. So we have the following slides will explain to you in details about the core and cavity. Yeah. So here just to show it to you that we do the inject and then we rely until cooling and then we eject. Yeah. Okay, so these are the sequence in detail. First, the mold is closed. Here is the core and cavity of the die and the mold. Okay, and then here on B is the melt is injected into cavity here using the screw. Okay, so it's inject into the cavity, right? Next, here the screw is retracted. So moving backwards. Okay, we retract the screw. Okay, so here we wait until solidification occurring. And finally, we eject. Okay, the mold opens and parts is ejected and drop down here. Okay, so these are the parts. Okay, before, let me just go back to the previous one, previous slide. So here, when you look at like this, the mold like this, you have to be familiar which one is core, which one is cavity. Okay, this one and this one. Okay, so I will explain next slide. Okay, injection mold consists of two halves. Okay, so core and cavity, right? So usually core is movable ejection half, and the other half is stationary injection. So this is cavity, this is core. Okay, as you can see at the bottom here, so this the process here. So you look at this animation, and you look at the bold near text. So just now, okay, we start from the here. Yeah, we put the materials in the hopper. Okay, and then here they start clamping, and then inject the molten materials here, and then they wait until cooling. Okay, and then eject, right? So the parts near we put it at the bottom here. Okay, so these are the nozzle, this is the heating element to make sure that the materials here melt before we inject into the die, into the mold. Yeah. Okay. Right. So as I mentioned just now, you have to be familiar about the mold. So these are the major components of the mold. We have the core and cavity. Okay, core here, and cavity is this part. So this is core. This is cavity. So core is the half of the mold that forms the backside of a part. So in general, the core material rises up from the core block and almost fills in the back of the cavity. Okay, biasanya core tu dia naik ke atas sikit lah, ya, rise up, ya. And the cavity, this is the half of the mold that forms the outer surface of the part. So it is characterized by the negative impression of the part carved into the cavity block. Okay. Um, all right. So here you can see the major components. After the part has cooled sufficiently for thermoplastics or cured for thermosets, so the molds are open and the part is removed from the mold using ejectors. Okay, so here you see the molds open. Okay, so now here the molds open. Okay, now okay, so they move here, right? And then the part is ejected. You see ejector pin here, ejector pin here. You see, okay, here they eject. These are the components, yeah. Okay, so this is the ejector pin. So once done, once solidified, they will eject. Okay, most open, eject, and parts is ejected, and then fall down. Okay, so these are pins that are attached. Okay, these are the ejector pin lah, right? So these are the component, yeah. The components together with the runner, gate, and etc. I will explain about the runner and gate in next slide. So an ejection system is needed to eject the molded part from the mold at the end of the molding cycle. Okay, so these the ejector pins. Ejector pins are always located on the core side, not cavity side, the core side, because we have core and cavity as previous slide just now. Okay, so ejector pins always located at the core side of the mold, since the core is the side that the part shrinks onto. Yeah, so these are the ejector pin and this guide pin. Yeah. Okay. Right. So this slide shows in detail about the injection molding components. Yeah, for example, like here you can see the sprue here. Okay, so this is the injection unit. Okay, this is the runner. These are the runner. The runner is the side that is the part that hold the component. Yeah, so these are the mold cavity. Yeah, these are the component lah. Okay, so the runner is holding this. All right. So distribution channel accommodates the molten plastic material coming from nozzle and guided it into the mold cavity. Okay, distribution channel. Yeah. Okay, so these are very, very important for you to know. So which one is pro, which one is runner, which one is gate, and which one is part. Okay, so this is pro. Okay, a tapered channel through which transfer molten plastics injected from the injector nozzle into the mold. Okay, so then they pass it to the runner. Okay, runner. So runner is a channel that guides and provide a path for the hot injected plastic to flow into the mold cavity. Okay, so these are the part lah. But before they pass to the part, they will see the gate here. So we call it the gate here. The gate is an entrance through which constrict the flow of the molten plastic enters the mold cavity. Constricts means there is small, very tiny area here. At the gate. Okay, it's like this lah. Because after this we remove, yeah, we remove. Okay, and this one will come always lah. Okay. All right, so this just to show it to you the typical products made by injection molding, including examples of mold. Yeah, so this is core and cavity, and these are the product. Okay, the mold and the product. So here just to show it to you the machines, we have the very bulky machine here. So the tonnage of the force applied to keep the dies closed during the injection of molten plastic into the mold cavities and hold it there until the parts are cool and stiff enough to be removed from the die. Okay, so this is hopper. Okay, so injection molding machines are usually horizontal. Okay, but we still also have the vertical. So you can see here, these are the hopper, and these are the screws. So they inject here. Okay, so they inject, and this is the mold tool. Okay, this is the moving pattern. Okay, right. So this is the drive unit of the screw. Yeah. Okay. Next slide. This slide show it to you the three basic types of molds. Okay. So we have cold runner, two plate mold. Okay, this is number one, and then I'll move to the next slide. Number two is cold runner, three plate mold, and the third one is hot runner mold. So I go back to previous slide. Let me explain one by one. Okay, the first one is cold runner, two plate mold. So this design is the simplest and most common. Okay, as you can see here. So just two plate, right? So this one on the left and on the right. So this is the sprue, this is the gate, and this is the part. This is the component 1 and 2. So sprue and gate here, runner. Okay, so here you can see. So once it's done, we eject. So here we inject the molten materials, and then we anti-solidify, and then eject, and it's fall down. Yeah. Okay. The second one is cold runner, three plate. Just now two plate, cold runner, two plate, and this is cold runner, three plate more. Okay, so here you can see 1, 2, and 3. Okay, here 1, 2, and 3. Okay, so the runner system is separated from the part when the mold is open. As you can see here. the runner is separated, yeah. So this one component here and the runner here is separated, yeah. Okay, so the runner is stay in the middle, yeah. Okay, the third one is hot runner mold. The molten plastic is kept hot in a heated runner plate. So here is kept hot. So that's why if you look at this one, the hot plate runner stays molten. Okay, so that's why it's still in the red color. Sorry, I put my mouse. Okay, so this one, yeah. So we inject and then fall down here. So this one remain hot. So that's why we call hot runner mold, yeah. So we inject. So this is the parts. Then we eject. Yeah? Okay, so we have other multi-component injection molding, also called co-injection or sandwich molding, which allows the forming of parts with a combination of various colors and shapes. For example, like this one, we have the blue and the red color. So they inject the which one? The blue one first. Okay, and then they inject the red one. Okay, same like this one. This one they use two injection nozzles. Yeah. Okay, next is insert molding, which involves metallic components such as screws, pins, and strips. As you can see here, the metal here are placed in the mold cavity prior to injection and then become an integral part of the molded products like this. So we put it here first, yeah. Okay. So these are insert molding, yeah. So we combine with metal. Okay, next is overmolding. This is the process for making products in one operation and without the need for post-molding assembly. So we just make once. Okay, one process. No need to do any further process after that. So it's just once. See? So this is the first one and the second one. Okay, material one and material two. Okay. So this is first shot and this is second shot. Okay. So forming process where a part is made of two or more subsequent injections building on the previous injection. Yeah. So the process capabilities for injection molding. Injection molding is a high rate production process and permits good dimensional control. So injection molding is a versatile process capable of producing complex shapes with good dimension, accuracy, and also at the high production rates. The methods of avoiding defects consist of the proper control of temperature, pressure, and also mold design modification using simulation software. Okay. All right. So these are another, they call it reaction injection molding, RIM, which is a process, a monomer and two or more reactive fluids are forced at high speed into a mixing chamber at pressure of 10 to 20 megapascal and then into the mold cavity. So you can see they mix the ingredient A and ingredient B. Okay, so these are the cavity. Okay, let me move to the third one, which is blow molding. Okay, blow molding is a modified extrusion and injection molding process. Okay, so in extrusion blow molding, a tube or preform usually oriented so that it is vertical. So we first extrude. Okay, first extrude the tube, yeah. Okay, so in some operations, the extrusion is continuous and the molds move with its tubing. See this one, yeah? We extrude and then we blow. Extrude and then blow. Okay. Okay, extrusion blow molding. First one, extrusion of the parison here, the yellow one. Okay. So the second one, parison is pinched here at the top and sealed at the bottom around a metal blow pin as the two halves of the mold comes together. So on the left and on the right, okay, the mold. And then number three here, the tube is inflated. See, just now it's like this, yeah. So now it's inflated so that it takes the shape of the mold cavity. You look at the yellow, yeah, what color? Okay, and then finally the mold is open to remove the solidified part. Okay, so it already solidified. Okay, so in injection molding, a short tubular piece, or we call it parison, first is injection molded into cool dies. Parison may be made and stored for later use. Yeah, as you can see here, we put the plastic powder and then it's become heated and melt. So we inject here and then we um, produce the parison and then we blow. Okay, you can see the details here. Yeah, so this is the blowing. The parison is injected here, and then around the blowing rod, and then we blow here. And this is the final part here. The blow mold is open and the part is removed. Yeah. Okay. Yeah, the same thing. Just to show you the detailed simulation. So these are the injection. So to make sure it is a proper condition, and then they blow, and then they discharge. Yeah? So multi-layer blow molding involves the use of co-extruded tubes of resins, and this permits the production of a multi-layer structure. For example, like we have colors and also uh, other materials. Yeah. Okay, so these are just to show it to you the machine of the blow molding where they produce many bottles. Yeah, they produce bottles like this one. You can see that they have the indexing machine here where you can see the three station here. One, two, first one, where is it? One, number one is here. Number one, they have the preform mold station, and then they pass to indexing machine. Number two, the blown mold station, and number three is stripper station. Okay. Okay, next process is rotational molding. So most thermoplastic and some thermosets can be formed into large hollow parts by rotational molding. So in this process, a thin wall metal mold is made in two pieces. We call it split female, not male and female, yeah? Just both female, split female mold, and is designed to be rotated about two perpendicular axes. This one, yeah, mold like this. So that's why we call it two split female, two pieces, yeah, two pieces split female, because same size like this, and they rotate, yeah, into perpendicular axis, okay, and then they can have this shape, and then finally they can have the product like this. Okay, so this is primary axis, this is secondary axis. A large variety of parts are made by rotational molding, such as storage tanks of various sizes, trash cans, bolts, buckets, housings, carrying cases, and footballs. So various metallic or plastic inserts or components also may be molded integrally into the parts being made by this process. Okay. So the process capabilities, rotational molding can produce parts with complex hollow shapes with wall thicknesses as small as 0.4 mm. The quality control considerations usually involve accurate weight of the powder, proper rotational speed of the mold, and also the temperature time relationship during the oven cycle. Okay, next process is thermoforming. Okay. Thermoforming is a process for forming thermoplastic sheets or films over a mold by means of the application of heat and pressure. So you remember, sheets or films, okay? And then we apply heat and pressure. So in this process, a sheet is clamped and heated to the set points above glass transition temperature of the polymer, usually by radiant heating and force against the mold surfaces through the application of vacuum or air pressure, like this. Okay. Here you can see the details process. Number one here, these are the sheet, plastic sheet. Okay, and then we apply temperature here. So these are the mold cavity, and these are the vacuum holes. Okay, so flat plastic sheet is softened by heating, and then the softened sheet is placed over a concave mold cavity here. Okay, then number three, a vacuum draws. So here we apply vacuum here, draws the sheet into the cavity. So here look at this one, yeah. Now it's straight, and after this is become heated, and then now it's shape follow the shape of the mold, yeah. Okay, and then the plastic hardens on contact with the cold mold surface, and the part is removed and subsequently trimmed from the web. Okay, because here you can see the clamps open and we can remove the molded parts. You can see this figure as well. Okay, we apply heat, yeah, heat. Okay, like this one. We put the plastic sheet of film, okay, and then we apply heat, yeah, and then they will follow the mold. Okay, so here the heated plastic sheet is positioned above the convex mold, and then here the clamp is lowered. The clamp here is lowered into the position, wrapping the sheet over the mold as a vacuum forces the sheet against the mold surface. So you apply vacuum, yeah. Okay, the process capabilities for the thermoforming. Typical parts made by the thermoforming are packaging, trays for cookies and also candy, advertising signs, refrigerator liners, appliances housings, and panels for shower stalls. So molds for thermoforming usually are made of aluminium because high strength is not required, hence tooling is relatively inexpensive. Okay. Quality considerations include tearing of the sheet during forming, non-uniform wall thickness, improperly filled molds, poor parts definition, and lack of surface details, because we know it's very, very thin, yeah, the film or the sheet. Okay, next is a compression molding. Okay, compression molding. In compression molding, a pre-shaped charge. Here, the charge, yeah, the pre-shaped charge of material or pre-measured volume of powder or viscous mixture of liquid resins, and the filler material is placed directly onto a heated mold cavity that typically around 200 degrees Celsius. So forming is done under pressure from a plug or from the upper half of the die. It is similar like closed die forging of metals. Yeah? Same, yeah. Same like closed die forging. So we apply pressure and then we eject. Okay, parts is ejected and removed, right? Okay. Sorry. Okay, the process capabilities for compression moldings, three types of compression molds are available. First is the flash type. So for shallow or flat parts, okay, and then the second one is flash type is this one, yeah. So we can see that the flash, we have the flash here, and after this, we need to remove the flash, yeah. The second one is semi-positive type for quality production. Okay, and the third one is positive type for high density parts. Okay. Okay. This is just to show it to you. Um, part A is positive, and B is semi-positive, and C is the flash, the one that have flash, and we have to remove the we have to trim the flash later. Yeah. Okay. Next is transfer molding. Transfer molding represents a further development of the process of compression molding. Okay, so this is the transfer molding. The uncured thermosetting resin is placed in a heated transfer pot or chamber here. And after the material is heated, it is injected into heated closed mold. So this is the closed mold. Okay, and then we inject here. Okay. So this is the material. Okay, and then is this the melton, and then we inject through sprue and the part. Yeah. So here then we eject. So eject, and then we can see this is the bottom plate here, and this is the middle plate. So it is the component, the blue one. Yeah. So these are the component. So here is the materials, and it's melton, and then we inject and apply compression here. Yeah. Okay. So that's why we call it transfer molding. Okay, the process capabilities for transfer molding is typical parts made by transfer molding are electrical connectors, okay, and electronic components. Many electronic components use transfer molding, yeah? Rubber, silicon parts, and also the encapsulation of microelectronic devices. The process is suitable particularly for intricate shapes with varying wall thicknesses. So the molds tend to be more expensive than those for compression molding, and some excess material is left in the channel of the mold during filling, which is later can be removed. Yeah. Okay, number 8 is casting. Some thermoplastics such as nylons and acrylics and thermosetting plastics, epoxies, phenolics, and also polyurethanes and also polyester can be cast into a variety of shapes using either rigid or flexible mold. Okay, and then centrifugal casting. This is the process similar to centrifugal metal casting and is used with thermoplastics, thermosets, and also reinforced plastic with short fibers. So these are the product. And number 9 is the foam molding. Products such as styrofoam cups, food containers, insulating blocks, and shape packaging materials such as for shipping appliances, computers, and also electronics are made by foam molding using expandable polystyrene beads as the raw material. So here, yeah, we use polystyrene beads. So as it readily can be seen upon close inspection here, these products have a cellular structure. So the structure may have open and interconnected porosity for polymers with low viscosity, or have closed cells for polymers with high viscosity. Yeah? Um, the structure for foam molding, as you can see here in the animation here. So this is a molding process used to make plastic products with a solid outer skin and cellular core structure. Okay, here they inject. So in this process, thermoplastic are mixed with blowing agent and injection molded onto cold molds of desired shape. They use the molds here is cold. So the rapid cooling against the cold mold surfaces produce a skin that is rigid and core of the part that is cellular in structure. So yeah, this is heating element. So it's heated, molten, inject, and then this the cold mold. Yeah. All right. So finally, this is the last process, which is processing elastomers. Elastomer is a rubber. Yeah. It is a natural or synthetic polymer having elastic properties. So the raw materials to be processed into various shapes is basically a compound of rubber and various additives and fillers. So the additives include carbon black, an important element that enhances properties such as tensile and fatigue strength, and also abrasion and also tear resistance, ultraviolet protection, and resistance to chemicals. Okay, elastomers can be shaped by a variety of processes that also used for shaping thermoplastics. Thermoplastics elastomer commonly are shaped by extrusion or injection molding. Extrusion being the more economical and the faster process. Yeah? So rubber and some thermoplastic sheet are formed by the calendering. process wherein a warm mass of the compound is fed into the series of rolls like this and is masticated or compressed and kneaded. Yeah, masticated is compressed and kneaded into a pulp. So sheet produced by this process subsequently are used in the morphomin. So the process is also used in the production of the various elastomer and rubber products. Yeah. Okay. Here you can see the example of the line producing a glove. Okay. So discrete rubber products such as glove are made by dipping a metal form such as the shape of the hand for making gloves. They dip the metal form repeatedly into a liquid compound that adheres to the form. Okay, you see here, they dip. Okay, so I think that's all. So I hope that you can gain some insight of the several processes we use to shape polymer. Okay. All right. So I think that's all. Thanks very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you guys.
Thank you, Doctor.
Are you still with me?
Thank you.
Okay.
Thank
Bye.
you.
Thank you.
Next week.
Thank
Yeah.
you,
See you next
Doctor.
week. Bye.
Thank you, Doctor.
Bye.
Happy
Bye-bye.
holiday.
Thanks.
Happy holiday.
Thank
Yeah.
you, Doctor.
Bye bye.
Happy Diwali. Happy holiday. Bye.
Bye bye.
I thought I'm
Bye
alone.
bye.
Bye.